Chapter 4.6, Formalizing Relations and Functions. When you're deciding whether a set of numbers or a graph is a function or not, the one thing that you have to remember is that each x only goes into one y. So in order for an equation to be a function, each x only goes into one y. If you've got a graph, then you've got to do something called the vertical line test. The vertical line test will state that if any vertical line only touches a line once, then it is a function. And if my vertical line touches a line more than once, then it's not a function. So let's go ahead and look at these graphs. So if you take a look at the first graph, if you make a vertical line anywhere on this this graph, it's only going to touch the graph in one location. So this first graph is a function. The second example, if you make a vertical line anywhere on this graph, you're going to notice that that vertical line touches the graph in 2 points. If it touches it more than once, it's not a function. So this particular graph is not a function. This third one can be tricky because if you put a vertical line over here, it looks like it is a function because it only touches it once. But if you were to put a vertical line right down there, you'll notice that that vertical line touches that graph 3 times. So once again, if it touches it more than once, it's not a function. And then let's look at this last one. On this last one, you'll notice wherever you put that vertical line, it's only going to go through that graph once. So, according to the rule, this is a function. All right. Next, we're going to look at mapping diagrams. Mapping diagrams always start with giving you a set of numbers. When you look to start a mapping diagram, you've got to separate the numbers by your x's and y's. So we're going to make an x's and a y's column. On the x's, you're going to take all the numbers in the ordered pairs that are x's, and you don't want to repeat numbers. So the first x we have is 0, the second x we have is 3, the third x we have is 3, so again we don't want to repeat numbers, and then the fourth x we have is 5. In the y column, you're going to do the same. The first y you have is 2. The second y you have is 1. The third y you have is -1. And then that fourth y is 3. In a mapping diagram, you're then going to match up the numbers in the x column to the y column. So with 0, the number that matches up to 0 is going to be 2. The number that matches up to 3 in the first set of ordered pairs is 1. And then 3 is matched up again to -1. And then finally your 5 is matched up to 3. In the beginning of this, we said that each x only goes to one y. So at the top of this right, each x goes to one y. sorry, what we're actually going to write is you cannot have the same x to two different y's. So cannot have same x to two y's. So in this first mapping diagram, we see that this 3, the x is going to two different y's. So because that x is going to two different y's, it is considered not a function. All right, let's look at the second set of ordered pairs. Again, we're going to start off with our x's and y's. We go with our x's, we start at -2, 0, 4, and 25. With our y's, we go 5, 15, 25, and then because we have, the last one is a 5, because we already have 5, we don't have to rewrite that 5. And then we just go ahead and match them up. -2 matches to 5, 0 matches to 15, 4 matches to 25, and then, I'm sorry, that is not 25, that is 5. 5 will then match back up to 5. And in this example, we don't have one x going to two y's. We've got two different x's going to one y, which is fine. So this one is considered a function. Good. So the one thing that you want to remember is your domain is another phrase for your x values, and your range is another phrase for your y values. So in this list of ordered pairs, you're going to write your domain and ranges out. So your domains are just your x's. So you've got 3, 4, 6, -1, and -2. For your ranges, you've got 4, 5, 7, -2, and -3. Again, your ranges is another word for your y's, and your domains is another word for your x's. All right, we move on. So function notation. In function notation, all we're doing is we are replacing our y with an f of x. So instead of this equation reading y equals 2x plus 4, it will read f of x equals 2x plus 4. So in this example, f of x equals -2x plus 4. The domain of the functions are 1, 2, 3, and 4, and we've got to find the range. Again, domains are going to equal your x's. So when you write these out, you will rewrite the problem. So with this first one, f of 1, because that's the first domain that we're given, equals -2 times 1 plus 4. When you do that in your calculator, f of 1 goes on to equal 2. and that's your final answer. This is how we want you to write it out. Next one, f of 2 equals negative 2 times 2 plus 4. When you do that in your calculator, your f of 2 equals 0. Next, we'll do f of 3 equals negative 2 times 3 plus 4. F of 3 equals negative 2. You're probably starting to see a pattern, and you could probably guess what this last one is. You've got f of 4 equals negative 2 times 4 plus 4. Your f of 4 equals negative 4. So for this problem, your range values include 2, 0, negative 2, and negative 4. That is your answer for that equation. Go ahead and try the second set on your own. Alright, so our last two problems of the notes today. A pizza costs $15 plus 35% per topping. What is my domain and range? This is a problem you should be familiar with. So again, when we look at this, our C equals cost of the pizza, and our T equals toppings. Our equation for this particular problem is cost equals $15 for the pizza plus 35 cents for each additional topping. So in this problem, our toppings are going to equal our domain, and our cost is going to equal our range. So our domain for this problem is if you decide that you're not going to buy a pizza, then it's going to cost you $0. And you could have up to infinity number of toppings. So your domain is $0 to infinity dollars because there is no end to the toppings you could put on the pizza. Your range is going to be $15. And let me clarify, if you don't have any toppings, your pizza is going to cost $15 because it's just a cheese pizza that'll cost you $15. So your range will be $15 to infinity dollars for pizza. Again, your domain is 0 to infinity. You can have 0 toppings to infinity, and your range of a cost will be $15 for a cheese pizza or infinity dollars for however many toppings you want to put on the pizza. Last problem. I'm flying on my jetpack starting at a height of 20 feet and then flying upward at 25 feet per second. Write an equation and determine my domain and range if the longest I can fly is 10 seconds. So again, we've got to write our equation And before that, we've got to figure out our variables. So we're going to use A. We're going to use A for altitude. And we're going to use T for time. Our equation will look like this. A equals our starting point 20 feet plus 25 feet per second. Our domain is time. And our range is our altitude. So when we start this off, after 0 seconds, how many feet in the air will we be? So after 0 seconds in time, our feet in the air will be 20 feet. Our max domain, or our max time that we can be in the air, is 10 seconds. So after 10 seconds, how many feet will we be in the air? You do 10 times 25 plus 20, and you get 270. And that'll be feet. And this will be seconds. Homework should be on Schoology.